So hello and welcome again, guys. All right, so we're looking at naming branched alkenes today. So this is the second part of the series. In the first video we looked at naming straight alkenes. We're looking at naming branched alkenes today. And of course, before we start, I just want to show you a simple way of knowing what branches are. Branches really are alkyl groups. So branches are alkyl groups. All right, some people say alkyl, some say alkyl. You're not going to get an oral exam on this, so it doesn't matter. You just need to know how to spell it. Alkyl groups have a general formula of CnH2n plus 1. Now, if I have an alkyl group which contains one carbon, I'm going to replace N with 1. So that would be C1, H, so C1, H 2 times 1 plus 1. So that works out to be CH3. Good. Now, because it is an alkyl group, we're still going to use, and it's an organic species, we're still going to use the same naming system where for the number of carbons. So since it contains one carbon, the prefix for that is meth. And since it's an alkyl group, we use the suffix -il, YL, so it's methyl. So just bear that in mind, that your branches are alkyl groups. Okay, so let's go on to our naming now. So we're naming alkene. So here's an alkene. Attach a double bond, and we're just going to put something there. Remember, we're using the skeletal formula, so therefore it makes life very easy for us. So here are the steps you will take to name this alkene. The first thing you want to do is find the longest carbon chain. So we're going to do that by counting the number of carbons which are joined together in a chain in every possible direction. So 1, 2, 3, 4. There you go. 1, 2, 3, 4. And then if I start from here, 1, 2, 3, 4, 5. So you recognize now that the highest number of carbons we get is 5. So you now need to find the prefix of 5. The prefix for 5 is pent. And of course, since it's an alkene, the suffix is always going to be "ene." The ending of the name is "ene", so it's pentene. Very good. Now you need to identify the position of the double bond. Okay, the double bond should have the lower possible number. So what we're going to do really now is we're going to number our carbon chain so that the double bond has a lower number. And to do that, we have to count from left to right and from right to left. So here we go. 1, 2. Notice the double bond is on the second carbon. It's between 2 and 3. So 1, 2, right? And then counting from right to left, 1, 2, 3. So counting from right to left, the double bond is on the third carbon. Counting from left to right, the double bond is on the second carbon. The rule says use the lower number. So we're going to use the lower number. We're going to therefore number our carbon chain from left to right. So that's 1, 2, 3, 4, 5. So now we can clearly see where the double bond is. It's between 2 and 3. So we say this is 2-pentene. Great. So now that we have highlighted the root name of the species, we now need to identify the branch and give the position of the branch. From the naming, from giving the position of the double bond, we clearly see where the branch is. And for those people who are a little bit confused, what you want to do is in starting out, you want to just highlight your longest carbon chain so that your branch will stick out like a sore thumb. So I'm just going to do that now. So you can take your pencil and you can highlight your longest carbon chain. There it is. So that's your longest carbon chain. This down here now becomes the branch. Okay? That becomes the branch. So now, great. So we have identified the main chain and then this is the branch. So what we want to do now, as I said, is we want to identify the branch, what it is and where it is. We already know where it is. It's at position number 3. So now to identify what it is. So what we do now is count the number of carbons in the branch. This branch actually contains one carbon, which therefore means that it is methyl, because methyl contains only one carbon. And branches are alkyl groups. So you see there. So this is methyl. This is the methyl. All right. So now we know what the branch is and we know where it is. We can write the full name. So we can write methyl here. Methyl. And then we can put where the methyl is, 3. So as you can see now, the name of this species is 3-methyl-2-pentene. And of course, the name tells you what the structure looks like. Okay? Okay, so here's our second example. We're just going to do 2 examples because I want to make sure you get it. So we want to name this branched alkene. Remember, first step, find the longest carbon chain. So we count 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. So the longest carbon chain is 4 carbon atoms long. And the prefix for that is bute. And of course, the suffix is -ene. So it's butene. Okay? Then now we want to number the carbon chain so that the double bond has the lowest possible number. So we're going to count from left to right and from right to left. 1, 2. When we count from left to right, the double bond is on the second carbon. It's between 2 and 3. When we count from right to left, 1, 2, the double bond is on between 2 and 3 again. So it doesn't matter which direction we count from, the double bond is between 2 and 3. Now here's the situation. Okay, so we can say that this is 2-butene, regardless of which direction we count. Now we want to identify the position and the identity of the branch. Okay, now we can do this either, well, one of 2 ways. We can say this is 1, 2, 3, 4. Okay, so the branch would be on position 3, or we can say this is 1, 2, 3, 4. Okay, now the rule says you want the sum of your double bond position and your branch to have the lower number. Let me repeat it. The rule says you want the sum of the position of your double bond and the position of the branch to have the lower number. So let's check. If I number from left to right, which is in red, my double bond is at position 2. So that's 2. We can write that down, 2. Then the branch would be at position 3. See it right there? Position 3. So that's 2 plus 3. And that's equal to 5. Now, if I number from right to left, my double bond is at position 2. You see that? So that's 2. And then the branch is also at position 2. And 2 plus 2 is equal to 4. Very good. So based on the rules, I would number this chain from left to right. So I'm just going to cross out those numbers now. Okay, from left to right. From right to left, I'm so sorry. From right to left. I would number it from right to left. So there you have it. 1, 2, 3, 4. So now I've identified the position of the branch. It's at position 2. Let's identify the branch. How many carbons are there in this branch? It's actually 1 carbon. And if it's 1 carbon, then we need to find the prefix for 1. So that's meth. And then add the suffix -il. So it's methyl. Then where is the methyl group? It's on position number 2. So this species is 2-methyl-2-butene. That's it. Okay, there are many other questions you can practice. You can find worksheets online. You could send me a message as well. I'm going to put my email in the description, g2academy@gmail.com. But you can reach out to me if you need help, if you want to explore this further. All right, thank you for watching, guys. I hope you have found this helpful. I hope it will help you in your studies on whatever you're doing with naming branched alkenes, rather, not substituted. We're going to look at substituted next in the next video. So thank you for watching.